Guys, Mr. Bowman here. Today's learning objective is in green. We are learning to identify parallel line angle types. So there's two parts to our learning objective that we need to be aware of. The first one is this parallel line stuff. What does that mean? What does it look like? And the second part is the angle types that relate to parallel lines. So let's start off going through just a fairly basic parallel line stuff, just so we can understand the parallel line parts of it. So a parallel line, they are two lines, often represented by an arrow at the top, but what we need to know about these lines is the distance between the lines is always the exact same. And that means the two lines, they'll never actually touch each other, they'll never cross. Kind of like some train tracks is how I like to think of parallel lines. So those two lines, they are our parallel lines. And in a parallel line example, there will always be a bisecting line that kind of chops through the middle of the line. So that's our bisecting line. And what that bisecting line does is, if you have a look, it kind of creates 8 angles in and around those parallel lines. And there is some relationships we need to be aware of for those angles. So let's write that down. 8 angles created. And those are the angle types that we need to be aware of. So within that 8, there's 3 different types of angles that could exist, and we need to be able to identify and apply the angle properties of those types. First angle type I want to have a look at is it's something called co-interior angles. And I'm going to draw another set of parallel lines. So here's my parallel lines. And they are parallel because I've got the arrow. And there's my bisecting line. So co-interior angles, they've got 2 properties. They are within the train tracks. And I'll explain what that means in a bit more detail. And they're on the same side of the bisecting line. So an example would be, let's draw this angle here, A and B. They would be co-interior angles, because if you have a look, the train tracks are the parallel lines. They both sit within the train track. And if you have a look at that bisecting line, the one going up and down, they're both on the left-hand side of that bisecting line. So A and B would be an example of that. And you also could have C and D. So let's say C and D here. So they're both on the same side of the bisecting line. They're on the right this time. And they're still both within the train track. So C and D. And the way I like to remember this one is they're in the same room. So co-interior, so if you have a look, if you think of this part as a room, they're in there, and this part, they're in that room as well. So the second angle property we need to be aware of is something called alternate. Oh, I spelt that poorly. Let's do that. That was meant to be RN. So alternate angles. And again, I'll give us an example. So there's our set of parallel lines. There's our bisecting line. And if we have a look, A and B, they would be an example of alternate angles. And they're slightly different to our co-interior angles. So we can see they're still both within the train tracks. So you can see that they're both inside the parallel lines. However, they are on different sides of the bisecting line, and that's what makes alternate angles different to co-interior angles. So different sides of the bisecting line. And yeah, that's what's different. So they are different there, but they are the same over there. Another examples, C and D could also be alternate to each other, but we'll just focus on A and B in this particular drawing. And the final one we need to be aware of, they're called corresponding angles. So corresponding angles, again, I'll draw my set of parallel lines. And there are my arrows suggesting they're parallel. That's a bad bisecting line. Let's draw that again. There's a bisecting line. So the thing we need to know about corresponding angles, I'll draw an example. So angle A and angle B, those ones down there, they correspond to each other. And the first thing you'll notice is they're not within the train tracks anymore. You've got one in and one out. So we're going to write that one in and one out of the train tracks. And the other thing you'll want to note is they're actually on the same side of that bisecting line. Same side of the bisecting line. So with corresponding angles, there's actually a lot more corresponding angles than there are for co-interior and alternate. So we've got A and B. You could also have a look, C and D over there are corresponding to each other. You could have E up the top there, F down the bottom there. They correspond to each other. And you could have the same G up the top there, H, and then I and J. So lots of different pairs of corresponding angles. So this video went through corresponding angles, and I'm just going to teach us one more shortcut, one more little trick to help us identify these. This trick relates to letters. So in our first example, we would have seen that C and D were co-interior angles, and if I draw that line, and that line, that looks like the letter C. If I'm at alternate angles, I can go across, and then I'm going down, then I'm going across again. That looks like the letter Z. And alternate angles, this one's going to be a bit weirder, but we have the one across, and the one going down. That is an upside down F. So you can use the C, the Z, and the F approach to double check that you've got the right angles. So thank you so much for watching, guys. I really appreciate it. If you manage to stay till the end, we'll see who actually stayed to the end, but maybe put Abra down in the comments below. Now let's get into heaps of practice.